Good day everyone! In this video, we will discuss about higher order derivatives. In previous lessons, we only dealt with the first derivatives of functions which can be obtained by applying various differentiation rules. Now, we extend this concept by finding the derivative of a derivative. This is called the second derivative. The second and subsequent derivatives are called higher order derivatives. We differentiate the second derivative to get the third derivative. The second derivative, the third derivative, and so on are called higher order derivatives or simply higher derivatives. The second derivative is of order 2 and third derivative is of order 3 and so on. Thus, we can define higher order derivative as the nth derivative of the function f is defined recursively by f prime of x, which is equal to the limit of f of x plus delta x minus f of x over delta x as delta x approaches 0 for n equals 1, and nth derivative of f of x is equal to the limit of n minus 1 derivative of f of x plus delta x minus the n minus 1 derivative of f of x all over delta x as delta x approaches 0 for n is greater than 1, provided that these limits exist. Thus, the nth derivative of f is just the derivative of the n minus 1 derivative of f. Note that the function f can be written as the zero derivative of f of x. In the notation nth derivative of f of x, n is called the order of the derivative. Let us consider the following examples. Find the fourth derivative of the function f of x equals x raised to 5 minus 3x raised to 4 plus 2x cubed minus x squared plus 4x minus 10. We differentiate the function repeatedly and obtain f prime of x to be equal to 5x raised to 4 minus 12x cubed plus 6x squared minus 2x plus 4. F double prime of x is equal to 20x cubed minus 36x squared plus 12x minus 2. To get the third derivative, let us get the derivative of the second derivative. So we will get third derivative of f of x is equal to 60x squared minus 72x plus 12. And finally, the fourth derivative of the function f of x can be obtained by getting the derivative of the third derivative. So we will have fourth derivative of f of x is equal to 120x minus 72. Another example. Find the first and second derivatives of the function defined by y equals 3x squared minus 4 quantity x squared minus 3x. Using the product rule, we compute for the first derivative to be y prime equals 3x squared minus 4 times the derivative of x squared minus 3x plus x squared minus 3x times the derivative of 3x squared minus 4. So we will get 3x squared minus 4 times 2x minus 3 plus x squared minus 3x quantity 6x. Simplifying it, we will get 6x cubed minus 9x squared minus 8x plus 12 plus 6x cubed minus 18x squared. Combining like terms, we will have the first derivative as 12x cubed minus 27x squared minus 8x plus 12. From here, using our solved first derivative, we can now obtain the second derivative by getting the derivative of 12x cubed minus 27x squared minus 8x plus 12, which is equal to 36x squared minus 54x minus 8. For our third example, let y be equal to 3x plus 5 all over x squared plus 4. Find the second derivative of the given function. Using the quotient rule, we will get the first derivative of the function to be x squared plus 4 times the derivative of 3x plus 5 minus 3x plus 5 times the derivative of x squared plus 4 all over x squared plus 4 quantity squared. Getting the derivative of 3x plus 5 and x squared plus 4, we will have x squared plus 4 times 3 minus 3x plus 5 times 2x all over x squared plus 4 quantity squared. Simplifying it, we will get 3x squared plus 12 minus 6x squared plus 10x all over x squared plus 4 quantity squared. For the numerator, we will have 12 minus 10x minus 3x squared, and for the denominator, we will get x raised to 4 plus 8x squared plus 16. Note that this is our first derivative. Hence, to solve for the second derivative, we will simply get the derivative of this resulting first derivative. For the second time, we can again use the quotient rule. So therefore, the second derivative is equal to the derivative of 12 minus 10x minus 3x squared all over x raised to 4 plus 8x squared plus 16. We will get x raised to 4 plus 8x squared plus 16 times the derivative of 12 minus 10x minus 3x squared minus 12 minus 10x minus 3x squared times the derivative of x raised to 4 plus 8x squared plus 16 all over x raised to 4 plus 8x squared plus 16 quantity squared. Getting the derivative of 12 minus 10x minus 3x squared and x raised to 4 plus 8x squared plus 16, we will have x raised to 4 plus 8x squared plus 16 times negative 10 minus 6x minus 12 minus 10x minus 3x squared times 4x cubed plus 16x all over x raised to 4 plus 8x squared plus 16 quantity squared. Simplifying the numerator, we will get 6x raised to 5 plus 30x raised to 4 minus 48x cubed plus 80x squared minus 288x minus 160 all over x raised to 4 plus 8x squared plus 16 quantity squared. We can now have this as our second derivative. Another one. Find the third derivative of the function defined by g of x equals negative 4x squared e raised to x plus 5x e raised to x minus 10 e raised to x. We differentiate repeatedly by applying the product rule and obtained the first derivative of x equals negative 4x squared times e raised to x plus e raised to x minus 8x plus 5x times e raised to x plus e raised to x times 5 minus 10 e raised to x. We have used the product rule for the first and second terms. Simplifying this, we will get negative 4x squared e raised to x minus 3x e raised to x minus 5 e raised to x. Since we have common factor e raised to x, we can factor that out and write our first derivative to be e raised to x quantity negative 4x squared minus 3x minus 5. But remember that we are after the third derivative of the function. Thus, we will get the derivative of this to obtain the second derivative of g of x. For the second derivative, again, we can use the product rule wherein e of x and negative 4x squared minus 3x minus 5 as our factors. Thus, we will have e raised to x quantity negative 8x minus 3 plus negative 4x squared minus 3x minus 5 times e raised to x. Multiplying e raised to x on negative 8x minus 3 and negative 4x squared minus 3x minus 5, we will get negative 8x e raised to x minus 3 e raised to x minus 4x squared e raised to x minus 3x e raised to x minus 5 e raised to x. Combining like terms, we will get negative 4x squared e raised to x minus 11x e raised to x minus 8 e raised to x. Again, notice that e raised to x is a common factor. So factoring it out, we will get e raised to x quantity negative 4x squared minus 11x minus 8. So this would be our second derivative. To get our third derivative, we will be applying again the product rule, considering e raised to x and negative 4x squared minus 11x minus 8 to be our factors. So we will get the third derivative to be equal to e raised to x times negative 8x minus 11 plus negative 4x squared minus 11x minus 8 times e raised to x. Simplifying it, we will get negative 8x e raised to x minus 11 e raised to x minus 4x squared e raised to x minus 11x e raised to x minus 8 e raised to x. Combining like terms, we will have negative 4x squared e raised to x minus 19x e raised to x minus 19 e raised to x, and factoring out e raised to x, we will get the final answer or the third derivative of the function to be e raised to x times negative 4x squared minus 19x minus 19. For our last example, if f of x is equal to e raised to x sine x minus 3 e raised to x cosine x, find the second derivative of f of x. We differentiate repeatedly, applying the product rule, and obtain the first derivative to be e raised to x times cosine x plus sine x times e raised to x minus 3 quantity e raised to x times negative sine x plus cosine x times e raised to x. Notice that we have applied the product rule on the first and the second term. Now, simplifying this expression, we will get e raised to x cosine x plus e raised to x sine x plus 3 e raised to x sine x minus 3 e raised to x cosine x. Combining like terms, we will get 4 e raised to x sine x minus 2 e raised to x cosine x. Factoring out e raised to x, we will get e raised to x quantity 4 sine x minus 2 cosine x. To get the second derivative of the function, we will get the derivative of this resulting first derivative of f of x using the product rule, considering e raised to x and 4 sine x minus 2 cosine x to be our factors. So, for the second derivative, we will get e raised to x quantity 4 times cosine x minus 2 times negative sine x plus 4 sine x minus 2 cosine x quantity e raised to x. Simplifying the expression, we will get 4 e raised to x cosine x plus 2 e raised to x sine x plus 4 e raised to x sine x minus 2 e raised to x cosine x. Combining like terms, we will get 2 e raised to x cosine x plus 6 e raised to x sine x. And factoring out e raised to x, we will get the final answer of the second derivative of f of x to be e raised to x quantity 2 cosine x plus 6 sine x. I hope that you have understood the lesson. For our next video, we will discuss about the chain rule. Thank you so much for listening and see you on our next discussion.